Okay, in a list of data, every value falls within some number of standard deviations of the mean. For example, if the mean is 50 and the standard deviation is 10, then a value x with between 40 and 60 is within one standard deviation of the mean. Because if I add 10 to 50 going this way, I get 60, and if I subtract 10 from 50, I get 40 going that way. And so that gives me one standard deviation of the mean. So let's use standard deviation to describe data for problem 3. So it says use the U.S. hurricane strike data from problem 2. Within how many standard deviations from the mean do all the values fall? So going back to problem 2, and this data set that they have here. So these are the strikes that we have. Okay, so as you can see, they've plotted all the points. And so they've taken the mean value, and we found the mean last time. Our mean was 17.6. And so our mean is 17.6 here. Our standard deviation was 3.5. And we found 3.5 as well. So what they've done here is they've taken it and they've added 3.5 to 17.6. And they came up to this point here. Then they added 3.5 again, and they came here. Then they came this way and they subtracted 3.5. And they subtracted it again. And they did that to see where all of their values fall. And when they see that their values come within going in the positive direction, 2 standard deviations of the mean, and within the negative direction, 2 standard deviations of the mean. So we can conclude that all the values fall within 2 standard deviations of the mean. Hurricane watchers can expect that the number of U.S. hurricane strikes in a decade will probably fall within 2 standard deviations of the 15-decade mean. Alright, so let's do it on our own now. It says use the Atlantic Ocean hurricane data from guided 2. Within how many standard deviations of the mean do all the values fall? So let's plot that data. I'm going to put it on my whiteboard here, and I'm going to try to make sure I have enough space. So we'll start here. We'll start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, and from my data, I know that there were 2 3s, there were 3 4s, and let me just show you what I'm referring to. So there were, when I'm looking at the number of hurricanes, there were 3 within a year. There were 2 3s that were noted. There were 1, 2, 3, 3 4s. So there 4 times I had, 3 times I had 4 hurricanes, and 1 time I had 5 hurricanes. So let me put that there. Then I have 1 7. 2 times I had 8. 2 times I had 9. 2 times I had 10. 1 time I had 11, and 1 time I had 14. Now my mean was about right here at 7.3. So if let's subtract first. No, let's add first. If I add my standard deviation of 3.2 It's about, the first one comes to about 10.5, so that's 3.2 I added. Notice that all my data still hasn't fallen within that. So I'm going to add 3.2 again, and this time I'm at 13.7, which is still not enough, so I need to add one more time, and that gives me at 16.9, which is off my chart. Sorry, this is 3.2. So for this one, I know I need to go at least 3 standard deviations. Let's check going in the opposite direction. So for the first one, I'm going to get to about 4.1. So I still need one more time. And then again, I'm going to subtract, and this time I'm going to get, again, off my chart at 0.9. Oops. That's 3.2. And so this point here is 4.1, and this is 0.9. And this is 10.5. And this is 13.7. So looking at my data, even though going in the left direction, I only need to go 2 standard deviations. I need to look at it holistically at all of my data. And so this going in this direction, I'm going 3 standard deviations. And so all of my data would have to be within 3 standard deviations of the mean. Okay, so now let's answer the last part. It says, how might the U.S. Federal Emergency Maintenance Agency use this information? Well, we know that the hurricane for the next couple of years is probably going to fall within 3 standard deviations of the mean that we've been given so far. So I hope that this helps.